Welcome to the third quarter final review. So question number 1 wants you to rank the following scenarios from the most accurate to the least accurate. So we look at the list of choices and decide which ones probably are the most expensive. And so we look at the number of trucks owned, the number of roofing nails, and the number of power saws. So think about it. If you were a construction company owner, which one would you be the most worried about losing? A truck, one roofing nail, or a power saw? And that'll help you decide. So in that case, trucks are more valuable. You'd be pretty upset if somebody lost a truck. So it's number 1. We need to have it be the most accurate counting. Then power saws is number 2, and then roofing nails. I'm pretty sure that every person that ever worked on a roof has lost at least 1 or 2 roofing nails and probably more. So that's our ranking. Problem number 2 wants us to, we have Sal who measured a piece of molding to be 15 inches. Sal is confident that the piece of molding is actually between what 2 values? So let's go to our slate and look at this. All right, so we have 15 inches. It's rounded off to the nearest whole inch. So what you do is you add 1 and you get 16 inches. You take your 15 inches and subtract 1, and those are inches also. So, not feet, inches. So you're pretty confident that your actual value is someplace between 14 inches and 16 inches, the most accurate measurement, right? Let's delete that. Let's go back to our PowerPoint and look at problem number 3. That's our answer. A big box store charges $89.89 for 3 sheets of plywood. How much does this store charge for 1? So let's go to our slate. The cost was $89.89, and we want to know how much the cost for 1 is. So we're going to divide it by 3. 3 goes into 8 2 times. 2 times 3 is 6. We subtract and we bring down the next number. 3 goes into this 9 times. Remember, the decimal comes straight up when you divide. 9 times 3 is 27. Bring down the 8. Again, that would go in 9 times. 9 times 3 is 27. Subtract and bring down the next number. It would go in 6 times. And we could keep going, but we know that there's more to come. This would go in, add the 0, would go in 3 times. Now, when you buy something at the store, believe me, the store is not going to round to the nearest penny. They always round up. So it was $29.96.3. So they will definitely charge you $29.97. It doesn't matter what value is in this place. This number is always going to become 1 bigger, because they want to make the money in their favor, not in yours. All right, pause the video at any time, teacher, if you need to. If not, we're ready to go on. So let's go back to our PowerPoint. Let's look at number 4. There's our answer. It says a resistor is marked 20 ohms plus or minus 5 ohms. Because no ohm or no resistor is exactly perfect, or very few are. What is the greatest number of ohms possible for this resistor? So let's go to our to our slate. We had 20 ohms plus or minus 0.5 ohms. Remember, this means plus or minus. To get the greatest value, we're going to take the plus sign. So I take 20 ohms plus 0.5 ohms. Remember to line up the decimal points. So I get a value of 20.5 ohms. If it asks for the least value, I take 20 ohms and subtract 0.5 ohms. This becomes, I need to do a little bit of borrowing, so this becomes 19 and that becomes 10. So I get 0.5 and 19.5. So this would be the greatest value. This would be the least value. And this is what the question asked me for, so here's my answer. All right. Pause the video if you need a second. Welcome back. Let's go back to our PowerPoint. All right, question number 5 is going to deal with the Pythagorean theorem. It says find the missing side or hypotenuse for the following right triangles and round it to the nearest tenth of a degree. So let's go to our slate and look at what we remember about right triangles. All right, so if this is the right angle, this is the hypotenuse. Remember, the hypotenuse is always the longest side. And let's see what it said. It said A. A is just one of the sides, but looking at my picture, this must be A. This is B, and the hypotenuse is always C. So the value they said was A was 7 feet, and it said that C was 25 feet. And we want to find B. So I know the Pythagorean theorem is A squared plus B squared equals C squared. And if you remember in the podcast, what that means is if you drew a square off of here, a square off of this leg, and a square off of this leg, the area in here plus the area in here would equal the area in here. So now let's fill in what we know. We know A squared, A is 5, so that, or I'm sorry, A is 7 feet squared. I don't know B, but C is 25 feet, and we square it. 7 squared is 49. When I square feet, it means feet times feet, which I get is feet squared. 25 squared is 625, and again, feet squared is feet times feet is feet squared. I want to get the B all by itself, so I'm going to subtract 49 feet from each side. And let's see what we get. We got B squared equals 576. Square root both sides. Punch it in your calculator. The square root of this is 24. Remember, it was feet squared, and when I take the square root of feet squared, it just becomes feet. So this is my final answer. All right. If you didn't have a calculator, you just try to estimate. I know 25 times 25 is 625. I know 20 times 20 is 400. So it would have to be someplace between theirs, and I would just keep trying. But you're allowed to use your calculator, so no problem. All right. Pause the video if you need to. Welcome back. Let's go on back to our PowerPoint, and let's try the next slide. There we go. All worked out. So it says a 25-foot ladder reaches up the wall 18 feet. How far from the ladder, or how far from the building should the ladder be placed? And notice I've already drawn you a diagram. So let's go to our slate and let's look at this. All right, so we're going to draw recreate the picture. Here's my right angle. So this is the building over here. It says it reaches up 18 feet. And the length of the ladder, which would be this, reaches up 25 feet. And they want me to try to find this, and they called it X. All right, knowing that this is across from the right angle, that means that this is C. This must be A, and this must be B, or they could be B and A, your choice. So here's the Pythagorean theorem. A squared plus B squared equals C squared. I know what A is. It's 18 feet, so I substitute that in. I don't know what B is, but I know C is 25 feet. Let's do the math and square it. 18 times 18 is 324. Feet times feet is feet squared. 25 times 25 is 625. Again, feet times feet is feet squared. I'm going to move the 324 to both sides. Do the math. I get B squared equals, when I do this, I get 301 square feet. So I'm going to take the square root of both sides. So in my calculator, I'm going to press in the square root of 301, and it came out to be 17.3. Square root of feet squared is just feet. So there's my final answer. Pause if you need to. Welcome back. Let's go back to our problem number 7. Oh, got the same answer. All right, a client wants a patio that's in the shape of a triangle. He wants the lengths of the patio to be 22 feet, 120 feet, and 122 feet. It wants to know, is this triangle in the form of a right triangle? And then they want to know why or why not. So in other words, I need you to prove it. So let's go to our slate and take a look at this. We have sides that are 22 feet, 120 feet, and 122 feet. The only one I really need to designate is the hypotenuse, and that's the longest side. So this is A and this is B. You could reverse them if you wanted to, but we're going to see if it fits the Pythagorean theorem. We're asking, is 22 squared plus 120 squared equal to, that's my question, 122 feet squared? So if we do the math, 22 times 22 is 484. And feet times feet is feet squared. And I should have put a feet. 120 times 120 is 14,400. And again, it's square feet. And 122 and 122 times 122 is 14,884 square feet. When I add them together, this side becomes 14,884. And these are square feet on this side. Got to make sure the labels connect. Square feet. It does equal to this. Both sides are equal, so that tells me it is a right triangle. And the reason why is the Pythagorean theorem is true. The Pythagorean theorem works. If these two guys were not equal to each other, it still could form a triangle. It just wouldn't be a right triangle. So teacher, pause if you need to. Welcome back. Let's go back to our PowerPoint. And let's look at this next problem. Oh, there it is. It's worked out. So it says your construction company has the following number of empty lots left. So in the first month, you have 54 lots available. Month 2, you only have 47 lots available. Month 3, you have 38 lots available. Month 4, you have 31 lots available. Month 5, 22. And month 6, you only have 12. So it wants you to make a scatter plot. So we're going to go ahead and draw a line of best fit. So here we go. What I did here was I made an XY axis. I put the months, because they came first, along the x-axis. Empty lots left, I decided to go by sevens because I had to get up to 54, I believe. And so then I just graphed it. After month 1, there was 54 lots left, month 2, 47, and so forth. So I made the scatter plot. Then I did a graph of the line of best fit. Notice I got to nail 3 of the points pretty well. And here we had a point above and a below, and here's a little bit below. So on that one, it's going to be up to what I think is close enough. So graph it. And I drew the line of best fit. Now, it wants me to find the slope of the line of best fit and explain what it means. So I reminded you of the formula for slope. Please know that you need to have that committed to memory. And let's go to our slate and see what we got. All right, first of all, I usually like to take the farthest points apart. So in month 1, there were 54 lots. In month 6, there were 12 months. And again, there's more than one right answer for this, so I'll be looking for your answer. So here we go. We subtract the y's over subtracting the x's. So I have 12 minus 54 over 6 minus 1. When I do the math, I get negative 42, and that was lots, over 5 months. You could leave it like that, or you could say negative 8.4 lots per month. What it tells us, it means that the company uses, and this is just an approximation, approximately 8.4 lots per month. Now, if you put on that they used 52 lots per 5 months, you could have also counted that, and I would have counted it correctly. Pause the video if you need to. Welcome back. Let's go back to our PowerPoint. And number 11 says, oh, there we go, worked out. Number 11 said, a roofer kept a table showing how many square feet he shingled. So after 2 hours, he'd shingled 1,600 square feet. After 4 hours, 3,200. After 7 hours, 5,250. And after 9 hours, 6,750. Now be very careful on this question because it's going to pick which points you use. It says, what is his average rate of change from 2 hours to 4 hours? So let's go to our slates and we'll work it out. Remember that the change in y over the change in x is the function at b minus the function at a over b minus a. So I'm going to pick the 2 points. After 2 hours, he had shingled 1,600 square feet. After 4 hours, he had done 3,200 square feet. And those were the values. So this is going to be A, and this is going to be my B point. So here we go. The function of B is 3,200 feet. It's like the Y value. The function of A is 1,600 square feet. Let's just label them square feet. Over the time, 4 minus 2 hours. When I do that, I get 1,600 square feet over 2 hours, which is 800 square feet. Square feet per hour. So that's all you do. So it's just like finding slope. It's just using a little bit of the notation for functions. So let's go ahead and pause if you need to. Welcome back. Let's go back to our PowerPoint and let's look at the next one. There's my answer. Now it wants from 7 hours to 9 hours. So let's go to our slate. We're going to use the same formula that the change in y over the change in x is the function at b minus the function at a over b minus a. And what we get here is it wanted us to use between 7 hours and 9 hours. So this first ordered pair is 7 hours, and he had done 5,250 square feet. After 9 hours, he had done 6,750 square feet. Again, I'm going to call this point A and this point B. So the function of B is 6,750 minus the function at A is 5,250. And those are square feet divided by 9 hours minus 2 hours. Oops, and this should have been a 7. Tried to do the math in my head. So what we got here was 1,500 square feet for 2 hours. When I simplify it, I get 750 square feet per hour. Okay, so pause the video if you need to look at this longer. Welcome back. Let's go back to our PowerPoint. And look, we got the right answer. Now question number 13 says, what's happening to his rate? It wants to know whether it's increasing, decreasing, or staying constant. Well, the first one was 800 square feet per hour between 2 and 4 hours. Between 7 and 9 hours, it had decreased to 750 square feet per hour. So his rate decreased as time passed. A reason, he might have gotten tired, or he might have had a more difficult location to shingle. So as long as you've given me a reasonable explanation, it'll be fine. So look at number 4. It wants us to find the missing side. And notice we only have one side given, and we have one side as an unknown. So what we're going to do is we're going to have to use something other than the Pythagorean theorem. So we're going to have to, our other tool is going to be to use trig. So let's go to our slate and look at this. So I'm going to go ahead and I'm going to recreate the drawing. Here we go. So this was 46, this was 32 degrees, and this was x. So from this reference angle, or the angle theta, we have to decide what sides we know. This guy's across from the right angle, so he's always the hypotenuse. This side helps make up the angle, so it's adjacent. So I have to pick from sine, cosine, or tangent. So sine is always the opposite side over the hypotenuse. Can I use that trig function? No, I don't know the hypotenuse and I don't know the opposite side. So this one's not going to work. Cosine is the adjacent over the hypotenuse. Well, I know how big the adjacent side is, and I'm looking for the hypotenuse, so I'm going to use cosine. So I say the cosine of 32 degrees is the adjacent side divided by the hypotenuse. Now the variable's in the denominator, so the inverse of multiplying by, or dividing by x is multiplying by x. So I get x times the cosine of 32 degrees equals 42. I want to get the x all by itself, so the inverse of multiplying by the cosine of 32 is dividing by the cosine of 32 degrees. Cancel these. In your calculator, you'll type in 42 divided by the cosine of 32. Make sure your calculator is in degree mode. And if you did it properly, x should come out to be 54.2 feet. Now let's see if that even makes sense. Well, the hypotenuse is the longest side. Is 54.2 greater than 46? Yes, so at least it's a reasonable answer. And there we go. All right, pause the video if you need a little bit more time. Welcome back. Let's go back to our PowerPoint and see. There's the problem all set up nicely for you. And then let's go on to number 15. Number 15 now has our angle theta at the top, and we have two others. Please know that this is supposed to be a right triangle, even though I neglected to put in the right angle down there. So let's go to our slate, and let's look at this triangle, and I'll put the right angle symbol in there. There we go. There's my triangle. This is the right angle. This is 26 degrees. This is 8, and this is x. So I know because 8 is the hypotenuse, my answer has to come out to be smaller than 8. So I look from what I've got here. I look across from the right angle. This is the hypotenuse. This is across from the angle that we were given, our angle theta. So that's the opposite. And remembering back to sine, cosine, and tangent again. The sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. And tangent is the opposite over the adjacent. Think about which side you'd used. I know the hypotenuse. I want to find the opposite, so I'm going to use sine. I don't know anything about the adjacent, so I can't use the other two. So I go the sine of 26 degrees is equal to x over 8. The inverse of dividing by 8 is timesing by 8. So in your calculator, you're going to push in 8 sine of 26 degrees. And if you get the correct answer, mine came out to be 3.5 feet. Or just 3.5. I don't think there was any label on it. But that's the work and the thought process behind it. So pause the video if you need to. Welcome back. Let's go back to our PowerPoint. We only have 4 more problems to do. Okay. So let's see. Yeah. This problem again is a right triangle. We know that the safety angle of a ladder needs to be somewhere near 75 degrees. And if my ladder is 25 feet long, how far up the wall can it reach? So let's go to our slate. And let's look at this. All right, here's the wall. Here's my ladder. This angle is 75 degrees, and my ladder is 25 feet. And I want to know how far up the wall how far from the wall is it? How far up the wall can it reach? This should be my x. So what I do here is I go, this guy is the opposite, and this guy is the hypotenuse. So we're looking at this angle of 75 degrees. It's right here. So this is the opposite and this is the hypotenuse. So we're going to use sine. Sine of 75 degrees is the opposite, that's x, divided by the hypotenuse. The inverse of dividing by 25 is timesing by 25. So in my calculator, I'm going to put 25 sine of 75, and my answer comes out to be x is 24.1 feet. So that's how far up the side of the building that the ladder can reach. All right, pause the video if you need to. Welcome back. Let's go back to our PowerPoint. And I have a wrong answer there, which I will correct. So I'm glad I worked these problems out with you. Now, if number 17, if you need a ladder to reach 36 feet up the wall, how long must the ladder be if we use a safety angle of 75 degrees? So we want to find out how long that ladder can be, and so that we can reach it. So let's go to our slate. Let's look at the picture. We know that the safety angle is going to be 75 degrees. We know we want to reach 36 feet up. So we want to find out how long this ladder is. So from this angle, this is the opposite, and this is the hypotenuse. So again, it's the sine. The sine of 75 degrees equals the side opposite divided by the hypotenuse. The inverse of dividing by x is timesing by x. So I get x times the sine of 75 degrees is equal to 36. To get the x all by itself, the inverse of multiplying by the sine of 75 is to divide by the sine of 75. So here x is going to be equal, and we get 36 divided by the sine of 75 is 37.3 feet. I know that it needs to be longer, so that at least is a reasonable answer. Pause the video if you need to. Welcome back. Let's go back to our PowerPoint and let's see what we got. So there we go. And let's look at the next problem. 18. We want to know that angle up there. Find the indicated angle in degrees. So let's go to our PowerPoint, or I'm sorry, to our slate. And let's put this drawing in here. Here's my right angle. This is the angle I want to find. This is 44 units long, and this is 24. So from this angle, I know this guy over here is the hypotenuse, but he's not in the problem. This guy's across the triangle. He's the opposite. The 44 helps make up the angle, so it's the adjacent. So I know it's tangent, because tangent is, it's SOHCAHTOA, the opposite over the adjacent. So here the tangent of theta is equal to the opposite, 24 over 44. Now I want to get theta all by itself, so what I'm going to do is I'm going to take the inverse tangent of both sides, because the inverse of tangent is inverse tangent. These cancel because they're inverses, so I get theta equals the inverse tangent of 24 over 44. Your calculator does not care if you simplify that fraction. I'm not going to, so I just punch in my calculator the inverse tangent of 24 over 44, and my calculator gave me, 28.6 degrees, and there's my answer. That wasn't anything, so I started to look at something else. So let's just make sure, and I'm going to double check it on my calculator. The inverse tangent of 24 over 44 is 28.6 degrees. So that's how big this angle is at the top. All right, pause the video if you need to. Welcome back. Let's go back to our PowerPoint, and let's see. There, we got the same answer. Now, we've got theta in a different location, and we've got different values. Remember what these sides are going to be. So let's go to our slate. We have 35. We have 47. Here's theta. There's my right angle, 35 and 47. I want to find out how big this is. So this guy is across the triangle, so he's the opposite. This guy is across from the right angle, so it's the hypotenuse. So we're going to use sine. And I think I left tail of the P. So we have the sine of theta is equal to 35 over 47. We want to get theta all by itself, so I'm going to take the inverse sine of both sides. So inverse sine and sine cancel off because they are inverses. So I get 30 equals the inverse sine of 35 over 47. And if you punch it in your calculator, theta will be 48.1 degrees. All right, pause the video if you need to. Welcome back, and let's go to the last problem on our review. The last problem, there we go. It says a ladder is placed against a 35-foot pole such that it touches the top of the pole. If the bottom of the ladder is 12 feet away from the base of the pole, what angle does the bottom of the ladder make with the ground? So let's go ahead and go to our slate, and let's take a look at what happens here. Here's going to be my pole. I'll make it just a little bit thicker. Here's my pole. Here's my ladder. And here's my right angle. It says that this is 35 feet tall, and it says the ladder is 12 feet from the wall. And I want to know the angle it makes with the ground. So this is my diagram. And then from here I look, this is the opposite side. This is the adjacent side. So I think that's tangent. So the tangent of my angle is equal to the opposite side versus the adjacent side. Again, I want to solve for theta. So the inverse of taking a tangent is taking the inverse tangent. What I do to one side, I've got to do to the other. So theta is the inverse tangent of 35 over 12. When you punch it in your calculator, you will get 71.1 degrees. I sure hope you feel better about taking the final in another day or two. Don't forget you can email me or talk to Mr. Luckow. Have a nice day.